Okay, so you're taking a quiz about vision and you're trying to study things that go wrong with the human eye so that you're not seeing things properly. So really quickly, the first thing I want to do is I want to review how it's supposed to happen. So what's supposed to happen with your eye is this. Light comes in through your cornea and your lens and it gets refracted. So the light that comes in gets focused down to a very small spot. And if everything works fine, the light rays cross over and you wind up with an image right here at the back of the eye in a tissue called the retina. So, yeah, I did say upside down. How in the heck does your eye see things upside down, but you think you see things right side up? Well, that's part of the magic of the brain, because the retina is this tissue and it sends a signal to the optic nerve, and then your brain says, oh yeah, this is what I see. So anyway, that's how it's supposed to work. So the focal length of the eye, in other words, the place where the light rays are supposed to cross over, it's about, I've Googled this a few different times, I forget every time. It's around 17 millimeters. That's the focal length of the human eye. So that's where the light rays cross over. So we'll switch to red here. Let's just say that you've got too much refraction going on. In other words, these light rays that I drew coming back to the back of the eyeball, instead of crossing over way back here, what if the light rays came in and crossed over too soon? Say maybe right there. If you had this sort of a thing going on, if your lens was, say, way too round and it did too much refraction, then you wouldn't be able to see stuff unless it was really close to your eye. Those people are called nearsighted. Eye doctors have another word for it that I always forget, so there you have it. So if you have too much refraction going on, then your focal distance is too close to the lens, too close to the front of the eye, so you can only see objects that are really close to you, because when you bring an object close to the eye, this point moves back to where we want it, back here. The same thing is true if your eyeball is a little bit too long. I don't know how many people that happens in or what, but let's just say that your eyeball, instead of being as long as it's drawn in this image, let's say that your eyeball was a little bit longer, like this. Then even if the light rays did cross over where they were quote-unquote supposed to, it would still be far away from the back of your eye if your eye was too long. So if you're born with an eye that's too long, you are going to be nearsighted, or if you're born with an eye that has too much refraction going on, you're going to be nearsighted. What can cause that? I would imagine that there's all kinds of causes. You know, maybe the muscles that control the lens. Who knows? There's lots of different things that could cause that. So what else could happen? Well, you could be farsighted. In that case, maybe you have not enough refraction going on. In other words, maybe I should clean this image up a little bit. Instead of the light rays crossing over right back here where we want them to, or the focal point being right there, what if your lens was too skinny, if it was too flat? If your lens was too flat, it wouldn't refract these light rays enough, or maybe this wasn't rounded enough. And in which case, the light rays would cross over, but on their way toward crossing over, and I guess the light rays don't really go back here because that's the end of your eye, but the focal point would be way back here. So these people, their image, the image that's formed by the eye is, you know, back behind the eye. So these people can't see stuff unless it's really far away. These people are called farsighted, because if you look at an object that's really far away out here, then that takes this spot and it moves it forward. So if you're farsighted, you probably have not enough refraction going on. Or just like with the last one, maybe your eye has a kind of a goofy shape to it. Instead of your eye being long enough, maybe your eye is a little too short. So even if the focal length is the right length right here, you need it to be way up here, but it's not. So maybe your eye is too short. So both of those problems can cause you to be farsighted. And once again, that problem could be caused by maybe the muscles in your eye, or maybe the shape of your cornea or your lens. So how do we fix these problems? Well, there are certain surgeries that can be done. There's a surgery where they they go in and they change the shape of your cornea. They use lasers, or I don't know if they do it anymore, but they used to do something called radial keratotomy. They would slice away that part of your cornea. I'm not an eye person or a doctor or whatever, but maybe there's surgeries where they change the lens. I don't know. But there are surgeries that can be done to do this. Or we can do something on the outside of the eye. So let me do this. I'll insert a new page here, drag in another eyeball. And let's just say that you were someone and your light rays, your eye was doing this. Your light rays were crossing over too soon and you wanted to move that spot back here. Well, the light rays that are coming in, what we need to do is we need them not to cross over so soon. So we need a lens that spreads those light rays apart. So one way to do that is a lens that is shaped like this. This lens is what we call concave. See how it's kind of, if you looked at it from this side, it's kind of caved in. So that's a concave lens. What happens when light rays come into this is they go in, and when they come out, they get refracted. So this lens takes light rays and spreads them out. So any light rays that make it into the eye are going to be spread out a little bit, and that's going to take this point right here and it's going to move it back. So that's what a concave lens can do. A concave lens can be used to fix your nearsightedness, where you've got too much refraction going on. Okay, let's do this. Insert another page here. And what if you're someone who has this going on? Your refraction is taking place, but it's too weak. So your focal distance is back here somewhere. Then in that case, what you want to do is you want the light rays to cross over sooner. So you need more refraction. So you need a lens that is rounded, maybe on both sides. I'm just going to draw it rounded on one side pretty much. So if you put this in front of your eye, what happens is the light rays come in. I'll draw them in red. The light rays come in, and this lens brings the light rays together. So it kind of gives your own tissues a helping hand. So if this lens brings the light rays in together, that's going to take this focal point and it's going to move it back up here toward the retina where we need it to be. And contact lenses do the same type of thing. A contact lens is just something that you put on the surface of your eye that has more or less one of these two shapes, either this convex shape, that's convex, or it has this concave shape, or it kind of approximates that, and that's how we can fix your vision. So I'm closing in on 8 minutes. Let me know if you find any big mistakes in this video and I'll shoot it again.